So, what is a complex fraction? What do you think, Em?
It's basically a fraction that's inside of a fraction.
Yes, it's a fraction inside of a fraction, and we don't ever leave them. There's going to be some hard and fast rules in here, about 5 of them, like you'll never leave negative exponents, never leave things unfactored. Will I say never leave a root in the denominator? No, that's fine, right? Another one is going to be never leave a complex fraction. So I'm going to go back and do 2 really simple ones just so you kind of see what's going on here. In the 4th grade, if you did 1/2 divided by 3, keep in mind it's really important where the primary division symbol is. So watch for that, because this, I'd read the longer one as primary or a bold one as primary. This is 3/2, right? This is what? 1/6. Yeah, this is going to be 1/2 times the reciprocal of the denominator, which is 1/6. You'll notice that when it was a fraction over a single term, these collapsed as a product, right? So like 2/3 over 5, 2/15. It just collapses as a product. So when you hear me say this collapses as a product, that's what I mean. I would multiply by 1/5, which in a sense is just going to collapse as a single product on the bottom. The next one over here, same thing. This is my primary fraction bar. So really I'd multiply by 1 over theta, but it's just going to collapse as part of a product in the denominator. And what do you think I'll clean that up to be? I'm going to cough and not do it in Clarissa's ear just a second. Oh, I'm super sorry. Hey, there's supposed to be muscles in here. It's all baggy. Anyway, oh, sorry, Clarissa. What am I going to clean up on that one, Gil? I'll circle it for you. What'd you say? I think I heard it. Yeah, that's actually tangent theta over theta, and it's done. Are we going to do ones like that? No. I'm now going to verge into the kind you do in pre-calculus and then tell you how it inserts itself in the calc, okay? I actually took your assignment today from a pre-calculus book. So we're going to make them a little harder, and there's going to be 2 methods to do them. Give me one method. What was the one that was in the summer packet? Yeah, find the LCD, multiply the top and the bottom by it, and clean it up. That always works. Sometimes it's not the best way, but it always works, and it's a good way. When there's 2 ways that are equal, I show you both. When I think one is way better, I don't even bother with the other. This is what I'm going to show you both, and you'll see on the key, it's about 50-50 how kids chose. They were actually taking that option. I'm going to do this one this way. So I'll show you both. Method number 1 is what you just said. Multiply, right, the top and the bottom by the LCD, then the term that all denominators go into evenly, and the smallest one. So I've got a 1, an x, a 1, and an x cubed. So I'll multiply it by x cubed over x cubed, which is 1. And Harry, when you multiply by 1, it doesn't do anything. It just gives it a facelift. So basically in the facelift will result in there being no more complex fractions. But it's going to be the exact same equivalent. I put this in parentheses, and I distribute it in. And it's just a matter of, and it works, and it's nice. It's just not always the cleanest way. So Liam, when I dump that in, what do I get? X to the 3rd on that dump plus, which is perfect, 2x squared. All over on the bottom, Tyler, excuse me, what do I get? 3x, perfect. And then minus 1. Yep, they cancel. When you do it this way, you have to really make sure you factor when you're done, all right? That's on some of them. They weren't getting the answers, and it's because there's some factoring along the way. Like right here, I can see they had to factor out a negative and that kind of thing. So make sure your final answer is factored, and if things cancel, cancel them out. So there's the top. Oh, so gross. Bottom doesn't cancel. And I'm done, and that wasn't too hard, right? Pretty easy, right? What do you think? Could you do it that way? And you'll choose to do about half of them that way. I'm going to show you another way to do it. So this is the LCD way. Method 2 is what I like to call crisscross applesauce. And I'm going to go back to about 4th grade. I'm going to do 2/3 plus 4/5, but I'm going to do it different than you've been taught. How are you taught to add fractions? Get a common denominator, change the top of one, the top of the other, keep it, and add them up, right? Right? And that works. But what also works is if you just go, Chris, what's 2 times 5? Plus cross, what's 3 times 4? And 10 plus 12 is 22 over multiply. Boom. I call this crisscross applesauce. It's nice, especially when these don't share a factor. Like if this was 6 and this was 18, I probably wouldn't do it this way, right? I'd still get the right answer, but I have to reduce at the end. So watch. It works for subtraction too. 11/12 minus 1/5 would be 55 minus 12, 43, over 60, and I'm done. So you can do it in your head, right? So try it. Go back to the 3rd grade and do 3/7 plus 2/5 in your head. Don't blurt it out and try not to write anything down. Actually, I'm giving you a really fast way to add and subtract fractions. Okay, now say it. Pretty nice, right? That also works if this was an x and this was a sign, x, and this was an e to the x. It doesn't matter what kind of fractions you're working with. You can always crisscross applesauce. I'm going to call that method 2. They're equal. I like them both, but this one tends to be more helpful for us. Like as the year goes by, I'm going to see that most of you gravitate towards this one because most of the time the functions are trig-y, and it works nice with trig. What do I mean by trig-y? Yeah, like it's got full of sines and cosines. They're not like this. So this was nice. It worked well. So I'll show you it work on this one. Method 2 would be to go Chris, x, plus, because that's the link. You always have to start in the top left, by the way. So you'd go x plus 2 over applesauce. You multiply those. Boom. There's the top as a single fraction. You can see it. 1 plus 2 over x, right? All over, and then I'm going to crisscross applesauce the bottom. So I get 3x cubed minus 1 all over x cubed. And I'm going to repeat. I go multiply Chris, multiply cross, multiply applesauce. When you have two fractions and you're dividing, what do you really do? Multiply by the reciprocal. And to ease our workload, if we just go times and flip this one over, Mrs. LaRue doesn't care if you just go like that. You don't have to like rewrite it all nice. That's fine. It's a means to an end, and this will get me there just as well as if I rewrite it. Now watch what happens. This cancels with this, leaving an x squared. Look at the blue. It's x squared times x plus 2 over 3x cubed minus 1. Do you see how it's exactly the same as the red? Do you see how it's factored, though, with the blue already? For the blue method, it comes out factored. For the red method, you have to factor at the end. The red method, though, is nice. I like it. So you decide. They were all over the place, and I don't care as long as you're accurate. So I'll do 2 more, and then we're, yep. Nope. Never distribute, never FOIL. We always like things factored. All right, so on this one, you might say, I don't see a complex fraction. I'd say you should. Right, Joe? Joe number 1, thing 1? Right? Why am I seeing complex fractions? Because I have what? I'm honestly, I can't hear. So I'm not saying you're wrong. I just didn't hear you. It's actually not. I do have fractions within fractions. Do you know why, Lilister? Negative exponents are actually fractions in disguise. So you're totally right. This is 1 over a. There's my first fraction. So actually, this is a hot mess. This is lots of fractions within a fraction, right? On the bottom, Hannah, what would this become? I have 2 of them. Yep. b over a to the third. Then you would decide what method you want to use on this one. Do you want to go common denominator? In which case, make sure you choose it correctly. What would the common denominator be? What denominator would be the smallest thing that contains every one you see? A cubed, b squared, multiply the top and the bottom by it, distribute it in, cancel, that'll work. Or, what could you do? Crisscross applesauce, and I'm going to go that route. Are you all right with that? I don't know. It's just because it's what we use most of the year. It's not that it's better. I get into a zone and I don't like to switch my methods. So on this one, I would say b squared plus a over what? ab squared. Crisscross multiply across, which a few years ago some girl said applesauce and it kind of stuck. So I always say crisscross applesauce. All over. So now I have a single fraction all over. And then I do the same thing. A to the fourth, Chris, plus b cubed, cross, all over applesauce, b squared, a cubed. I now have two fractions, right? And when you do that and you're dividing, I'm actually going to multiply Kelly, right? By the what? Yeah, so let's just rewrite the bottom one flipped over. This one's actually a little less painless. Sometimes there's more steps, but it's just kind of easy. Like it's just kind of mindless work when you do crisscross applesauce. Where the other way you have to kind of think of reducing and canceling. So it is kind of, I do like it better, I think, but I'm not 100% sure I do. So I'm going to flip this over. What did I say you can do after you flip it over? Yeah, go ahead and just go like that for me. I don't need you to waste time rewriting stuff. And now, if you cancel, so let's go cancel things. My b squared's gone with my b squared. My a's gone with my a cubed. And I'll write my answer as a single fraction. So my final answer to this is a squared times b squared plus a all over a to the fourth plus b cubed. And I'm going to pause for a second. That's my final answer. That's what you would see on the key. If Harry had done it with a common denominator, I'll show you what the difference would have been. When he's done with his common denominator, he's going to have a squared b squared plus a cubed on the top. And what would you have to then do? Factor. So that way you have to do some factoring on the back end. There's even. So I would always say to do the crisscross applesauce, though, for the trig. So this is triggy. Liam, I already called on you. How about Kyle's sister? But I don't remember your first name. Ashley. Why is this a complex fraction even though I don't see it in my face? Yeah, and we're always going to take advantage of that. So we'll go sine theta over cosine theta. There's my fraction all over. Boom. I'm going to crisscross apples. This is usually what results in the calculus. You'll do like an integral or a derivative, which you don't even know how to do yet, and this will be there. And you'll go to the back of the book, and you'll see something that looks completely different. Watch how different the answer actually is once you clean it up. Are you ready? So I'm going to choose crisscross applesauce because it's really clean on this one. I would go sine theta, boom, cosine theta on the Chris. Are we good with that, Jade? Madison, plus sine theta on the cross, right? What's my denominator going to be? Cosine theta. That's the top as a single fraction. That's this. But it's all over 1 plus cosine theta. So watch what happens. When there's a fraction all over something else, it collapses as a product. It'd be 2/15, right? So this will actually just collapse as a product. That 1 plus cosine is going to go here. So you do all of your calculus in a few weeks, and you go look it up in the back of the book, and you won't see that. Because number one rule is always do what? Factor. Does anything factor up there? Yes. And when I factor, things start to happen. And if you don't factor, sometimes they don't. And you're like, oh, I just wasted my time factoring. But the minute I pull out a sine theta, watch what's left. Cosine theta plus 1. Watch what the answer in the back of the book is going to say. Way different than that one, right? Do you see it? What's going to happen now? You've got it. Go ahead, tell me. Yes, she's going, all right. Addition's commutative, so that can go. Be careful with subtraction. If these were there, could I cancel them? No. But how about these? Can I cancel them? Yes. What do they make? -1. Yeah, they're complete opposites. This is a +5, -5, minus. Or you could think of this one as being a negative, right? -5 plus x. But they're opposites. So that happens. This one, it took a while to get a key up here. Because I think it was this one. So either this one or this one. There's a -1 that things cancel and they didn't see it. I think it was, I'll just clue you in your last hour. I think there was something like this. And they didn't cancel it, and so their answer wasn't looking right. All right, so what'd you say the answer was? Tangents, because she's seen sine over cosine. So that's it on complex fractions. One other thing that you won't have homework on, because you should already know it, it's just in case. I'll test you on it, though. I'm going to give you 12 parent functions, and you're going to match them to the function. So let's create it. When you're done, I'll pass out the worksheet. What do you think one of them is? Go ahead and blurt. Y equals x. Let's even do y equals plus or minus x. But yeah, parent function for a line. We better know that, right? Y equals x, y equals -x. Y equals x squared is another one you'll need to write. If you can't recognize those, that's one of those things where I say, oh, we're in the wrong spot. There's a couple on here. You might go, oh, I forgot that one. Got another one for me? How about Joe number 2? Yep, x cubed's another one. Or f of x equals x cubed. You know, I'm using that notation, but yep. Y equals 1 over x. They missed that one. That one was our 12th one last time. They just didn't want to give me that one. It's Brad, right? Do you even know what the graph looks like? Yeah, it does do this, but let's talk about y just in case Harry's like, I don't remember. You could always plug and chug, right? So if he lets x be a 1, it'd be 1, 1. If he lets it be a 2, it'd be 1 1/2. A 3, it'd be 3, 1/3. Do you see how it's approaching the y-axis, 1/4, 1/5? Will it ever get there? No, but if you go to the left of 1 and put in a fraction like 1/2, what's 1 over 1/2? It starts to climb. 1 over 1/10 is 10. But again, I have an asymptote. So it's going to look like this here. And it's going to look like this over here. Now watch something that's kind of interesting. That means you better know what this one looks like too. Don't write it on your notes, but it's the same thing. Except it's what? People always say write 5 because I think you get taught that it's the opposite of what you'd think it'd be, right? Or if it's minus, you actually go 5 to the right. But it's actually, a better way to explain it is because the asymptote moves, right? Where's the asymptote on that one? Over 5. Didn't you ever kind of, when you first learned it, go, why am I going to the right when there's a minus? That used to kind of, when I was younger, I'd be like, all right, I'll do it because my teacher said. They'd say it's exactly what you would think if you're going up and down. But if you're going left and right, if it's plus, you go left. And if it's minus, you go right. And you're like, okay, and you did it. But it's actually about the shift of an asymptote. So right here, it moves at 6 left, but it's because the asymptote goes to where? If I had 1 over x plus 5, sorry, it'd be at 5 to the left, right? So we got that. That's good. Got another one for me? We got lots. What? Square root, did you say? Yep. Y equals square root x. Perfect. I call that one the shout out function because it just goes, yay. All right. Got another one for me? Yep. Yes. That one, I want to discuss a little bit. I know you know it's a v. I don't know if you understand why or if you really get what absolute value means. When you're little, what do they tell you about the absolute value? They say it's always, yes. And then if you have a really good elementary school teacher, they'll say, yeah, it's always positive, but because it's a distance from 0. But I don't know that you ever get taught its true definition. Absolute value function is really a piecewise function. If I were to say, what's the absolute value of x? What do you think most people tell me? If I say, what's the absolute value of x? They say x. That's not true. Because what's the absolute value of -3? It's not -3. The absolute value of x is not x. unless x is positive. So it's actually a piecewise function. Watch me write what this is. This is actually x. It is itself. 1, 1, 2, 2, 3, 3, as long as x is greater than or equal to 0. It's y equals x over here. It's that part, right? But when x is negative, it's not x. What is it? The opposite of x. Yeah, it's negative x. It's actually a piecewise. It's actually piecing together two lines. That's why it makes a v. I saw a couple hours today where they went, oh, I never thought of it that way. That's a calculus way of thinking about it. It's a piecewise function. It's y equals x meets y equals negative x. Does that make sense? That's why it makes that nice sharp v in there. All right, we got what? 6 more. We have lots. Throw another one at me. ln, that's on. Yep, y equals natural log x. That'll be in the mix. That's one a lot of kids forget. You guys forgot it during Kahoot, so that, and we use it a lot. So we'll throw that one on there. Throw another one at me. Sine and cosine. I'm going to put both of those. Y equals sine x. I'm even going to go function notation. Sine x, and let's do cosine x. They look very similar, so make sure you don't get too wrong on the test for goofing them up. Whether you do like a Sahala, Kahala, or Walala, or whatever, I don't care. But I just say sine 0 is 0, cosine 0 is 1. And then I know exactly what they look like, right? Just remember what happens at 0 and you've got their graphs locked in. All right, we got 3 more and really 5 more because there's 2 I'm going to throw on the bottom. So you still have some you can give me. No, we don't really care about that one. It pops up in the homework twice. Exponential with a specific base, e. E to the x and e to the negative x pop up for us. Not much in the first semester, but do you remember what they look like? Who said that? Was that you? Gil, what does e to the x look like? Yeah, at 0, anything to the 0 is 1. E to this e is like close to 3. It's 2.7-ish. So it's going to go up really fast. But then as I go negative, it'd be 1 over e squared, 1 over e to the, it's going to asymptotically approach that. So great. And e to the negative x is similar. All right. I'm still missing one. Oh, here. It's y equals a. It's so easy we forgot. The horizontal line through a. Sorry. Why does it bug me when people say a straight line when I say what's y equals 3 and they say a straight line? That bugs me. All lines are straight, right? So make sure you're more specific. There's 2 extras that I'm going to throw down on the bottom that would be nice to know. This guy. Does anyone know what that one looks like? If not, I'd like you to go right here and start plug and chugging it to see it form. I would start at 1. And then go 2, 3, 4, and then I go to a half. Yeah, there, almost. You just did it a little backwards. You went like this. It actually goes like this. We're going to call it the volcano function. Here you go, watch. 1 squared is 1, 1 over 1 is 1. There's an anchor. If I put in a 2, it's going to go all the way down to 1/4. If I put in a 3, do you see how it's going to approach that y-axis, x-axis really fast? Will it ever get there? No, it's a horizontal asymptote. We'll talk about those a little more tomorrow. If I put in a 1/2, though, watch what happens. Square it, 1/4. Do you see what's happening? It's going to go up to 4. So when I do the fractions, it shoots up. So it's got this. It almost looks like 1 over x, but it's quite different. Because what happens over here? What, Joe? Exact same thing, right? Because negatives and positives squared, it doesn't matter. I call this the volcano. Right? When I talk, I'll say it makes a volcano graph. And you'll be like, all right. The other one that's nice to know, but not until chapter 3, is the cubed root of x. So I'll just throw it. It's not on your first test. It's just a nice to know. That one. All right, we are done. So your homework will be, I would love it if you worked together on this one. Actually, for the unit circle, I didn't encourage it at all because that's something your friends saying, oh, the answers were 3 over 2 doesn't help you at all. But on this one, they had some really good work going on. The key's up there. I need people with good phones to volunteer to take a picture of part of the key and then post it in a Schoology post. What was that? Yeah, you can. You can do it as like an update or something. Yeah, they were able to do it. I don't know how they do it. That's why if you can't figure it out, someone will be able to. Sure, that'd be great if you did all of them, and then you can just like post and then add an image, and it'll be Oh, I'm gonna turn off my mic. Bye, Clarissa.